This is the circuit diagram. This is the DHT11 sensor and the Raspberry Pi. Already I told you DHT11 sensor has 3 pins. First one is the VCC, which is connected to 5 volt. The middle one is the data pin, which is connected to GPIO pin number 4. And the last one, the black one, is ground pin, which is connected to ground pin of Raspberry Pi. Now I will discuss different components of Raspberry Pi. This is Raspberry Pi 3B Plus. I'll open the case. This is Broadcom processor. This is Wi-Fi and Bluetooth module. There are 4 USB ports for connecting your keyboard, mouse. This is Ethernet port for connecting Ethernet cable to get the internet through Ethernet. This is audio port where you can connect your headphone and microphone or speaker. This is Pi camera slot where you can connect your Pi camera. This is HDMI port through which you can connect your LCD display or monitor or TV, whatever you want. Guys, I'll show you the SD card. This is the SD card. In this SD card, you have to install the Raspberry Pi OS. After installation, guys, you can see here, you can insert it into this SD card slot. That's it. This is micro USB type B port through which you can connect this wire, and now you can connect this wire to your laptop for getting power. This is LCD display slot. You can connect small LCD over here. But this is the port through which you can connect your LCD TV or monitor, all these things. But point to be noted, this is HDMI port. If you have VGA port in your monitor or TV, you have to use one adapter to convert VGA to HDMI. Then only you can connect to this port. There are 40 GPIO pins over here. Each of the pin having different functionalities. For example, ground pin, VCC pin, or you can say these are the pins, the GPIO pins, which can be connected to your device or the sensors according to your requirement. This is the blue one, is called the printed circuit board. So already I told you this is the type B cable. The one part is connected to this Raspberry Pi, another part is connected to the laptop or your computer, whatever you want. Now I'll assemble all these components for this project. This is Raspberry Pi. Already I have discussed about that. This is DHT11 sensor which has 3 pins. A positive, there is red one, will be connected to 5 volt of Raspberry Pi. The middle one, that is data pin, will be connected to GPIO pin number 4 of Raspberry Pi, and the negative, that is ground, will be connected to ground pin of Raspberry Pi. Now I'll connect this sensor to this Raspberry Pi. First I'll connect this pin, that is positive pin, to Raspberry. So connected. So now I'll connect the ground pin to this one. So now I'll connect the data pin to this GPIO pin number 4. Now I'll connect my micro USB type B to this Raspberry Pi and to my laptop. So as you can see, the power is on. So now I will tell you how to install DST11 library or Adafruit library. Guys, you can see the commands already I have discussed earlier. So now this is the code. So you have to copy paste the right API key over here in this code. This is my API. So guys, you can see Adafruit underscore DST dot read underscore retry. So that will have two parameters. One is the DST11 sensor type and another one is the data pin number, that is 4. So this function will read the data from the sensor and store it to RS, that is the humidity variable, and T is the temperature variable, and return humidity and the temperature after converting into the string to the calling function. So guys, you can see I have written one function, the def get sensor data, that will return temperature and the humidity value but in the form of string. So now guys, you can see the main function. So you have to give the API key from the command prompt when you are executing the program. Okay. And this is the base URL we have, and guys, you can see there is a while loop where actually we are taking data from the sensor, get sensor data, and it will be uploaded into this ThinkSpeak by URL leave2 dot URL open, then base URL plus the parameters, that is field 1 and field 2, that is humidity and temperature. You can also print f dot read function. So guys, this is the visualization screen. Actually, you can see two graphs in ThinkSpeak in private view or public view, temperature and the humidity. Now I will open advanced IP scanner. Click on scan. As you have seen, I have connected Raspberry Pi and ultrasound sensor to my laptop. Okay, so as you can see, this is 192.168.0.12, that is blue, that is active. So I'll copy this IP. Minimize. Click on remote desktop. Then copy. Then connect. Yes. Give username is 5 and Password is raspberry. This is my Raspberry Pi interface, guys. Let's go to terminal. This is the code. Already I have explained, guys. So as you can see over here, the same code already I have discussed. This is the adapter underscore dst dot read underscore retry. It is taking two parameters on the dst level, sensor type and the data pin number. And I have written one function called get sensor data. So it is called over here. You can see in the main function. Here we have this while loop. Okay, guys. So now I'll show you that how we can execute this program. So I'll go to terminal. Now I'll open terminal to execute the program that will upload temperature and humidity data in ThinkSpeak. As you can see, this is the Python file. Already I have executed earlier this program. I have to give write API key over here to identify my channel. Enter. I'll show you that data is uploaded. I'll open my browser. Please wait. As you can see, last entry less than a minute ago. So if I check, yes, this is 19 July, guys. You can see the time is 17:02. Okay, guys, this is the humidity. Okay, there you can see Monday, July 19, and time is 17:02. Over here also, sensing temperature 28 degrees. So this is the date and time is same. Okay, that means data is uploaded. Okay, still uploading going on. So I'll minimize it. Once again, I'll go to Raspberry Pi. Okay, so now I'll show you how you can take directly data from ThinkSpeak Cloud, and after that, how you can apply machine learning algorithm on this data, and you can predict some value, or you can do the analysis on those data by using ED Explorer data analysis. So now I'll go to my drive. Okay, so as you can see, this is the program already I've written. Is wait. So this program will take direct input from the cloud. So this program will retrieve the live data from ThinkSpeak, because already I have shown you that the Python program is running in background, and this particular program is uploading data in ThinkSpeak. this temperature and humidity data. So that is the thing. So now I'll show you the code. Guys, you can see over here. This is the import pandas SPD. That this particular library used to read the CSV file. Okay, so we'll take input CSV file. Okay, from ThinkSpeak Cloud. Okay, guys, this is the math.lib for plotting, or you can say display some plots. This is the Seaborn library. This is also for mathematical plotting. This is the API I've used to retrieve the data directly from ThinkSpeak Cloud. Okay, there is a live data, guys. So guys, I'll just run the code after that. But first I'll explain. This one is the to read the CSV file. Already I told you. So I have used the library called pandas, and as you can see, that's df.live.head, that means will print the first five values or top five values, whatever you can say. And then after that, guys, you can see over here there are a lot of NA infill. That is the we are receiving temperature over here, but not receiving the humidity due to some lag or internet issues. So these are the NA infills. We'll remove this one. That will clean the data set. So what we have received from ThinkSpeak. And then after the cleaning, this is the actual data set. That means we are removing the all NA field. There is the not a number field. Guys, you can see the function live dot drop NA. So then after that, we'll just save the file, the CSV file after cleaning. So now, so what actually I did, so because whenever we are taking the live value, so here we have only small amount of values. Okay, so that is not enough for any analysis. That's why I have prepared one data set for you from the Raspberry Pi with DST11 sensor for you only, and we'll include this data set, that is feed4 okay .csv, which has a lot of temperature values, right? And we'll use this file to analyze rather than the whatever the live data we are receiving. Okay, that will be useful for analysis. Okay, so if we want that we will analysis the live data, that means we not get a good result, right? Because live means so we have only small values. Okay, not because we need at least 10,000 values. Okay, so this is the data set whatever I have included feeds4.csv. So guys, you can see a lot of any infills as longitude, latitudes, and all these things. So we'll remove all these columns. So that's why drop in a field, and then after that we are getting only temperature and the humidity, and also we have removed like that is the entry ID and the created at and all these things. So we want only temperature and humidity value. So that is why we have removed all these values, right? Like drop in a, and then we just created at and then entry ID and all these things. Then you will get this particular data set. Okay, after cleaning. So because we are printing only top five values because the head function will print top five values. Then this is the humidity array. As you can see, this is field one, this is the temperature array. Okay. So then after that, we are doing exploratory data analysis. Already I told you guys, you can see. So this is the distribution, the temperature value distribution. As you can see, the more or less the temperature 30 degrees centigrade is occurring around 60% of time. Yes. Okay. As you can see. Okay. So and then humidity is more or less 50% of time is around 95 and all, right? Around 95. And this is your range plot, the regression plot. Already I have shown you earlier in my presentations. This is the mean value. Okay. So as you can see, SNS Seaborn library. we have used to rich plot. So now I'll split the data set into train and test data set. Like you can see over here, we have used sklearn model, selection import, train test split. Okay, so this is the now I'll create the model. So we have used linear regression. This is the equation for it, like as a certain equations, and this is the mean square error. And so guys, you can see this is the linear regression model, and this is the model fitting, and then we are predicting the humidity value from the temperature. As you can see, 94 point something, and also we are predicting for humidity values. And this is the mean square. As you can see, MSC is for test set and the trend set, the MSC value. So the drawback of linear regression is that it takes a lot of outliers, that is outlier points. So that's why we use the lasso. So now we are using the lasso, and then we have the linear regression with the lasso, where we are not using the outliers. And this is the model equation, and this is the model fitting, and it also predicts the humidity is almost 93.5, and then we are predicting for humidity values from the temperature, and then also we have calculated the MSC, as you can see, mean square error for test and train. So this is the actual explanation of the code. So please remember, we have used sklearn library for uh, linear regression as well as the lasso. And for plottings, we have used matplot as well as the seaborn library. Okay. So now I'll execute the code. As you can see, so first I have to include the feed4 file. Now I'll upload the feed4 file first. Please wait. Continue. As you can see, feed4 is uploaded. Feed4.csv is uploaded. So now I'll execute this code and show you how the program gives the output and how you can take data and clean it, and also how you can do the analysis and also the prediction. Okay, so click on run, guys, run all. We're executing this program on Raspberry Pi. As you can see, the values here, guys, you can see the temperature and the humidity value, the field 1 and field 2. Right, so I'll show you the file also, and this is the feed4 analysis. This is the file, that is feed.csv, actually taken from ThinkSpeak. Guys, this is a live one, live data, you can see. You wait. This is the value, and guys, you can see here we have the temperature as well as the humidity. Guys, temperature is the first one, the humidity is second. As you can see, okay. But after cleaning, but the problem is that here we have received the almost correct value. So after cleaning, this will produce feeds.csv. Feed.csv, the inputted file. After cleaning, we got this feeds.csv. When I can download it, but problem is that we have received almost all these values. So that is why no error no in any field, but in practically it may be the case due to some issue. Okay, guys. Now I'll start doing analysis. Already analysis done, as you can see. So this is the analysis of feed 4, guys. But there are a lot of in field in the different latitude, longitude, elevation, and status. We have removed this one, guys. Already have explained this one, and this is the after removing we got these two values. That is the field 1 and field 2, and then this is the humidity array, and this is the temperature array. Then we did the exploratory data analysis. But guys, I can show you that this is almost the same. The temperature, I guess, around 30 degree centigrade, and the humidity also the same. I can also run this thing for you once more. I can also run it for you. This is after cleaning. To run, you can just cell wise running. You can just shift and enter. Then you get this one. Okay. So then this one. Just shift enter. You just run all this individual cell. You can add the code also if you want. Is it? We are getting the same distribution for temperature and the humidity, because I have shown you before running the code that is exactly the same, because fit for having same value. As you can see over here, this is the range plot, and this is the lasso model. Just I'll show you that how you can add the codes, guys. You can see there is a, you can add the code, or you can add the cell and enter the code over here if you want. This is the code, and this is the text. If you want to give any comment, you can click on text, and like this, you can click on text. If you want to give command, or if you want to add code, you just click on code, guys. And this is the mean square error and the predictions values. So I think it is more or less same for both the cases. So here we have this value, guys. As you can see, I think it is a bit less as compared to RDS. If you're not adding this, you remove this one, guys. We don't want to add, you can remove the cell. This is the value which is less than the above model, that is normal linear regression. So that is why we have the value difference. So previously I think I have shown you above 10,000, but now it is 4 to 5,000 range. Okay, so this is the more or less idea about how we can run machine learning algorithm on Raspberry Pi. Thank you.